Hey guys, this is Mr. T with the next video on the measurements topic. This will be about accuracy of measurements, and it's going to be getting you to think about something that, some stuff that you wouldn't normally consider with stuff that you normally do in everyday life, which is measuring things. Obviously, when we measure stuff, we use an existing scale, and you trust that scale to be correct. Why? Because what you're doing is lining up your object with the scale that you're using. You're comparing them, and that's how you decide how long something is or the size of it, right? Some of these existing scales would be rulers, thermometers, tape measures, anything that you use to measure properties of objects. These scales always consist of multiple markings or divisions, and when we're measuring, what you're doing is saying that the item is the size of the very closest marking that it lines up with. So I've tried to illustrate that here. I've got a ruler with centimetre markings there, the main ones, and obviously those smaller ones are going to be millimeters because there's 10 of them for each centimetre. I've drawn an object as well. It's lined up with 0, so let's say I was measuring this. I've lined it up with 0. It's reached up to here, so I am judging based on the line how long this is, and well, it's less than the 4.5 line there. It's probably not as far as the 4.3 line, so we're going to be saying, like if I was measuring this, that it would be 4.4 centimeters, which is 44 millimeters. And you've probably done that a million times before, but you have to this year and beyond consider that's not 100% accurate. It's only approximately 4.4 centimeters. It could actually be anywhere between 44 millimeters and a plus or minus a half mil. Okay, so it could be anywhere between 4.4 mils plus or minus half of a millimeter, and so that could be between 43.5 mils and 44.5 mils. These two numbers here, the 43.5 and 44.5, we call boundary values. Okay, so the measuring tools are only as accurate as that, like in the example above, because it's accepted that any measurement is only accurate to within plus or minus a half of the very smallest division that you used in the scale to take that measurement. So if we look at that ruler there, yes, there's centimeters here, but what is the smallest division? Well, it's the millimeters. So it's an accepted practice that you can only be as accurate as a measuring tool to within a half of the very smallest division it has on the scale. So below a half or above a half, right? So in here, 43.5, 44.5, we've calculated the boundary values. So a lot of your questions are going to ask you to find the boundary values or the range that the measurements can be in, but also it'll ask you to just state what the measurement would be. So to give you an idea of how you would state the final measurement while considering the error, what you need to write is just find the average of the boundary values, and then you write plus and minus, and then it'll be half of the difference in the boundary value. So the difference would be the large boundary, the higher boundary, minus the smaller one, and then you put your units there, and that is how you would state it if it's not just asking for the range. Okay, so we're going to be doing some examples just to show you how this process works. Let's say I measured a pencil, 13.8 centimeters, 138 mils, with a normal school ruler. What are the range of values it could be? So it's just asking us for the range, okay, which is basically the boundary values. So just getting my calculator ready. 138 millimeters it is, based on the measurement. And what is the smallest graduation of the ruler? Well, it's a millimeter, so it can be accurate to within half a millimeter. Okay, so the measurement could actually be between 137.5 millimeters and 138.5 millimeters, because I've just taken half a mil or added half a mil to 138. Okay, that's the range. It hasn't asked for a statement of the actual measurement, but this next question will be. So this example is a tile is measured with a ruler. Difference is it's only got a 1 centimeter graduations, 1 centimeter markings, and we measure it to be 12 centimeters by 10 centimeters. So actually, before we can even do that stuff as well, we have to do some maths, because it's giving us 2 measurements here and we need to find the area. So what are the boundary values for the area of this tile? Well, firstly, we need to go we need to find the upper and lower boundaries of each of these things. So length could be 12 plus or minus, what is the smallest graduation? A centimeter, so it could be 12 plus or minus a half centimeter. And the width could be 10 plus or minus a half centimeter too. So what could these be between? It could be 11.5 centimeters to 12.5 centimeters. And the width could be 9.5 centimeters to 10.5 centimeters. This question is only asking for the boundary values. I'll give you an example of how to find the statement anyway. So what are the boundary values? Well, what's the lowest area that it could be? Well, the lowest length it could be would be 11.5. The lowest width it could be would be 9.5. So the lower boundary for the area would be 11.5 times by 9.5, 109.25 square centimeters. Alright, so that's the lowest it could be. The highest, sorry, I shouldn't say upper, highest area would be potentially 12.5 times by 10.5, 131.25 square centimeters. Alright, so the other thing that we could do is, I need to move this though, I've got no more space. The other thing I wanted to show you here is how to find the actual answer statement if it wasn't just asking for the boundaries. And I gave you instructions for that just above here. If I wanted to just state the final measurement, I just need to average the boundary values plus or minus the difference in the boundary values. Okay, so measurement would be, if you were asked to just state the measurement in 1, not the boundary values, would be, so the average of these two, the upper and lower boundaries, so it's going to be 109.25 plus 131.25 divided by 2, because there's 2 numbers, plus or minus, and look back up here, and the plus or minus is going to be half of the difference between the boundary values. So what's the biggest boundary? 131.25 minus 109.25, and halve it, so your answer is going to be, put that in my calculator, 109.25 plus 131.25, divide that by 2, that's going to be 120.25 plus or minus, finding the difference, 0.25 minus 109.25, 22 divided by 2 is going to be 11 square centimeters. Alright, so you would do that if it's asking, can you just state the measurement? Alright, if it's asking for the range of the values, then you do this, you provide the boundary values. And yeah, that's it. Hopefully that helps you for that exercise, and I will see you in the next video.